Well, hello and welcome to another Dev Nation. We have another exciting live broadcast today. We're going to be talking about Apache Camel. All right, so Apache Camel, hopefully you've heard of that project before. It's all about integration patterns, but more importantly, what we're going to have today is working within the context of Kubernetes. So that's where you get a chance to see something very cool. So up next is Nicola. He's one of the key contributors to Apache Camel and specifically the Apache Camel K project. Nicola, you're up next.
We'll start the presentation. Hope you can see the screen. Okay, so these are the topics that we are going to cover today. So first, I will give you an introduction about Apache Camel, that is the base project that we work on. And for those of you that don't know anything about Camel, then we will talk about this awesome project, Camel K. I will show you a cool demo. Then we'll talk about the relationship between Camel K and Knative, then with Quarkus, and what's next in the roadmap of Camel K. But first of all, let me introduce myself. I am Nicola Ferraro, working as software engineer for Red Hat. Later, Luca Burgazzoli will join me doing the second part of the presentation. We both work together on Apache Camel, Camel K, and Synthesis, and a lot of other open source projects. But today, we are going to talk about Apache Camel and Camel K. So, what is Apache Camel? Apache Camel is the most complete open source integration framework. It's the Swiss knife of integration. It has more than 10 years of development, but it is one of the most active Apache projects because it gets a lot of contributors every month. So it's based on enterprise integration patterns. It supports more than 300 components using a powerful DSL. But before talking about what an integration framework is, let's talk about integration. So what we mean by integration. Whenever you have two systems, system A and system B in the picture that have to communicate, but they were not designed to work together, you have an integration problem. Usually systems use different transport. One may use web services, the other may use REST services. One may use asynchronous communication, the other one may be synchronous using Kafka or ActiveMQ or whatever. But even if they use the same transport, they for sure have different domain models. So you have to map between objects of system A and system B and back and do other calls. So when you integrate the systems, but Camel is about all that. Camel is the glue between disparate systems. Camel can help integrating systems, whatever they use to communicate. And it helps you because it's an integration framework. It's a toolbox, so a set of tools that you can pick and use to solve your integration problem. And what are these tools? One of the most important tools that Camel provides is this, Enterprise Integration Patterns. This is a book from 15 years ago, written by Gregor Hope and Bobby Wolf. And it is still actual because integration problems are still the same. We have added more problems probably recently, but they are still actual. They describe problems and solution, recurring problem and solution when you have to integrate system. For example, this is a list of some of the integration patterns present in the book: content-based routing messages based on their content, and splitting messaging and reaggregating them, fixing out-of-order messages, enriching the content of some messages, and other patterns that are present in the book. Camel was originally based on this book, and it contains almost all the patterns that were present in the book, but not only them, because a lot of people contributed over the year, a lot of other patterns. For example, you can find in Camel, for example, the Saga pattern for achieving consistency in microservice architecture, or even the circuit breaker pattern for avoiding cascading failure when you integrate systems. So a lot of other patterns have been added. Where do you use this pattern? So the basic building block of Camel is the Camel route. When you write Camel, you write Camel DSL in Java or XML. Here we have two examples, but we have also other languages, you can use other languages. The XML is important because there are some visual tools that helps you to design routes graphically. But let's focus on this Java DSL. So a route starts from an endpoint. In this case, we have the file endpoint here, and then ends in one or more other endpoints. In this case, we have the JMS endpoint. So these two lines of Java code means hey, Camel, take all the data, so all the files that are present in the data inbox on my hard drive, then for each file, transform it into a JMS message and send it to the queue named order. So with this two-line of file, you do a lot of things already, and Camel also marks the file as completed for you and manage the errors for you with just these 2 lines of code. But you can also use enterprise integration pattern when you design routes in Camel. So for example, let's start from the file endpoint and then take all the files in the inbox directory, then split the file. So we'll take each single line of the file, then we transform each line into an XML message. For example, you can use JSON or whatever, and then send it to an ActiveMQ destination, or you can use Kafka. So Camel is based on this concept of endpoint, and you have a lot of components corresponding to these endpoints. And when I say a lot, I mean a lot. So this is the full list of components back to, I think, 1 week ago, because last week we have added other 2 components probably. So you can find whatever. So there is Zookeeper, Elasticsearch, MongoDB, Cassandra. You can connect to Facebook, to Twitter, to Telegram, to Slack, to a JDBC endpoint. You can use gRPC, HL7. So whatever you need, it's here. Camel can connect to anything thanks to the components. That is the major power of Camel. So to recap, Camel is made of routes, so a powerful DSL where you can write routes using enterprise integration patterns, and it provides a lot of components to connect to anything. This is Apache Camel, the most complete integration framework. And Camel can run on popular runtimes like Spring Boot, Carafe, Wildfly, even Thorntail, any microprofile server, or Quarkus. Luca will talk about Quarkus later. It runs as a library. You can put Camel routes inside your application when you write your application. But this is not the only way to run Camel, because today we are talking about another way to run Camel DSL in the cloud, and we are talking about CamelK. So CamelK is a new project that we have started last year at the end of August after the summer holidays. And it is about running integrations in the cloud, running Camel DSL in the cloud. When I say cloud, I mean Kubernetes or OpenShift. It's written in Go. Apache Camel is written in Java. Apache CamelK is an operator written in Go that runs Camel in the cloud. And it's a sub-project of Apache Camel. It's available on github.com Apache Camel-K. So look at the code and download it from the repository if you want to use it. There are some releases there. So this is what CamelK is about. So we've noticed that there are a lot of use cases where people don't want to deal with runtimes like Spring Boot and Thorntail. They just want to integrate system. And what they have to do if they want to integrate system is to write the Camel DSL. So the Camel DSL is complete. It's anything you need to do to integrate system. And then with CamelK, they can write the integration DSL in a file, in a simple file. You can use Java, but you can use also a Groovy script, a Kotlin script. You can use also JavaScript if you want. You can use also the XML provided by the Visual Tool. So once you write this file, CamelK is made of a client tool called Camel with the K at the beginning, Camel. So you take this file, Camel run integration.groovy, and your integration runs in the cloud. So you don't have to deal with containers, building containers, and doing the deployment on Kubernetes or OpenShift. That is just an enhanced version of Kubernetes, nothing more. So it just runs in the cloud. So this is the high-level architecture of CamelK. You have your development environment where you write your integration code. You can have also auto-completion and suggestion from the plugin. With the Camel CLI tool, you type Camel run integration, and then the Camel CLI tool take your integration code, wraps it into a custom resource in Kubernetes, and upload it to the remote cloud. Custom resources in Kubernetes are a way to extend Kubernetes functionalities by adding something more. And we have added an integration custom resource to Kubernetes and other sub-custom resources that CamelK needs for it to work. A custom resource is usually managed by an operator, and we provide the CamelK operator. So the CamelK operator takes this custom resource and converts it into running containers and running deployments. So it does it in a really quickly. So this is the loop. You change your integration code. The integration code is synchronized remotely into the remote cloud, and then the Camel K operator immediately change the deployment. In less than 1 second, you have a redeployment of your application. But I don't know if you believe me or not. I will show you a simple demo. So I'm going to build with Camel K a chatbot. So if you have Telegram on your phone and a QR code reader, actually you don't need the QR code reader, just use your camera if you have an iPhone. You can use it later after I build it. So let's write some code together. So I have installed Minishift in my machine. Minishift is a minified version of OpenShift with all the functionality of the real version, but it runs locally. You can install it really easily. And then I prepared here a file. It's an empty Java file. I'm going to write some code, so to integrate, to build this chatbot. So let's start writing some Camel DSL. Let's start from the Telegram endpoint. That's this endpoint. The plugin suggests that I have to provide an authorization token to talk with the bot. So here I'm using a property placeholder instead of the real token. And then I log every message, the body of every message that is sent to the bot. This is the first integration that I want to run. What can I do to run it? Oh, in this Minishift namespace, OpenShift namespace, Camel K operator is already installed, but I can type camel install to install it. It's really easy to use. So now I just take the authorization token of the bot, and then what I do is camel run the name of the file routes.java -p token equals to this token, and I'm using dev mode. As soon as I press enter, you will see here that a pod is already running remotely. So you see here that there is a local process, but it's not a local process, it's a remote process. So this integration is running in the cloud. What you see here is the streaming of the logs that come from the cloud back to my machine. So you see here live what's happening there in the cloud. Let's do a rolling deployment. For example, now I just want to avoid that you push messages to this bot because the bot is public, and then I filter using a simple expression. So I'm just telling Camel, hey, I just want to see messages sent by myself. This is my ID on Telegram. Then I save, and you see here a rolling deployment that immediately will deploy another version of the application with this. So let's start communicating with the bot. You see here, send start. This is the Telegram chat. Hey, and then you see the message here. So let's do something more complex. Just convert the body to string. It means using the Camel auto-conversion feature to just take the content of the message, not the body, the from, and the ID, etc. So then do a choice. We are doing content-based routing in this case. So when the content of the message, in this case, the body, to lower case, I don't know, you don't know the Camel DSL, but just follow me. It's really easy to understand. When the body to lowercase, you can use Java methods, contains the word chuck, and now some of you may already understand where I am going. If it contains chuck, I will do something. Otherwise, it's really natural. I discarded this message. So what we are going to do if the message contains chuck? We are going to consume an external API. So this is a nice API that I found on the internet, but I'm not responsible for what it returns. We can contact it using the HTTP endpoint, but since it's deprecated, I'm using the HTTP4 Camel endpoint. It's icmdb.com. ICMDB, probably you know more imdb.com, the Internet Movie Database. Well, ICMDB.com is the Internet Chuck Norris database. So it has a nice API that returns some random jokes about Chuck Norris. So let's do something with it. So let's, for now, just print the body that is returned there. So rolling deployment in the cloud, streaming of the logs. Hey, you see that hey is discarded, but if I write Chuck now, I get some messages from that API. I don't know if you can see it, but I read it for you. It's a JSON data with a type and a value property, and then a sub-object that contains a a joke. I don't want to read them, but I will read some of them, but you will use it later probably. And so it's JSON data. What we do with JSON data in Camel, we can unmarshal that. So using, for example, the JSON library. And then we want to transform the body because we don't need the full JSON data. We just want to focus on what? On the body property called value, and then the sub-property called joke. So let's save, rolling deployment. Let's try again. Tack. And then we have only the sentence. So Chuck Norris can access the DB from the UI. A lot of sentences like that. And then the last thing that we have to do to complete the chatbot is to send back this data to the Telegram chat, no? So just use the Telegram endpoint. So save, rolling deployment, and then I write Chuck here, and then I have a sentence about Chuck Norris. Anytime I do it. So Chuck Norris can unit test entire applications with a single assert. that's really cool. So now I let you use it. I remove the filter because now only me can use it. So now it's deployed. Note, I have done, I don't know, 10 rolling deployment of the application while I developed it in few minutes. This is the power of CamelK. There is a video also recorded here of what I've just done in live coding. You can use it. Let's go back to the presentation. If you can scan this code and use the bot or just contact CamelK bot. And now I'll tell you why I choose this demo, because it's an example of integration where you have two systems. Now you have from one side the Telegram system, from the other side the internet Chuck Norris database. They were not originally created to work together in any way. But at some point, this is the developer life. There is some business people that enter the room and say, hey, we have to connect these two systems. How can you do? You can change one of the two systems to talk with the other, but the risk is to couple them. For example, in this case, you cannot change not Telegram, not the internet Chuck Norris database. So the best solution is always to put something in the middle, like Camel, so the glue that connects the two systems, because Camel can talk with each system. And if you want to integrate system, there are usually hidden issues that we have to solve. For example, what if the Chuck Norris database becomes slow? We can stop calling it and return some baked response to the user, like Chuck Norris will kick your back shortly, something like that. Or if Telegram is not reachable at some point, we can retry sending the message after a few seconds. These two things are one-liners in Camel. So look at the code, you will see that they are really, really easy to implement. So, but now we are going to talk about another topic, and it's CamelK and Knative. So, CamelK loves Knative. I don't want to go much into detail about what Knative is, but tell you that Knative is a series of building blocks for adding serverless capabilities to Kubernetes. So when I say capabilities, I mean custom resources, like the integration that I've talked about before. So this custom resource allows you to do serverless thing on Kubernetes. And these custom resources are divided in three major areas: build, serving, and eventing. Let's focus for now on serving only, because it provides some primitives. So custom resource to create services that can scale up and down depending on the load. So including if there is no one using your service, the service can also scale down to 0. And this is really a nice thing. And what we do in CamelK about Knative, well, Knative is not present by default on Kubernetes or OpenShift. It can be installed. And when you install CamelK on top of a cluster that has the Knative, the operator automatically configures itself with the Knative profile. It means that when you run the integration, Camel run the integration file, instead of creating a standard deployment, the CamelK operator will create a Knative serving service. And this changed a lot the way it behaves, because a Knative serving service is a really cool thing. Let's focus on this API. You see here, REST post. So we are going to define a method post on a path endpoint. So this is a REST service that we are going to expose using CamelK. And for each message received by this endpoint, it will forward to two systems, System 1 and System 2, that can be one of the 300 and more components supported by Camel using a custom protocol. When you say Camel run this integration, it creates a Knative service. But there should not be always something running. So at some point in time, the Knative service can have some pod running, or the pod may be killed. So a Knative service is like a Schrodinger cat. It can be live and dead at the same time. Oh, you have the only way to know if it's dead is to try. But fortunately, as soon as a new request arrives to the Knative to the Kubernetes namespace, even if if the pod is dead, Knative is able to create a new copy of the pod. And then the request is intercepted by Istio or here, and then when the pod is created and ready, the request is forwarded to the pod that does your code, execute your code, your integration code. And as soon as no requests start to come for a certain amount of time, the pod is killed again. So this is really cool, and this is offered by CamelK together with Knative. And it works also for scaling up. So you have a lot of requests coming at some point. You can configure it to scale up to, for example, 3 pods, so that the load is managed. But as soon as the load finish, you have nothing in your namespace. This cool things works also with Knative eventing. We have not talked about Knative eventing, but I tell you there are some other primitives for eventing in Knative. So for example, the most important one is the channel. A channel is a publish subscribe resource like a Kafka topic or any JMS topic. So someone can send events to a channel, and other services can subscribe to a channel. So when you run an integration like this from Knative channel A to system 1 and system 2, so the CamelK operator creates a Knative service and then a Knative subscription. The Knative subscription links the channel to the service. And this is how it works. So when someone sends an event into the channel, it will be a cloud event. So go for cloudevents.io to look on how they work, but they are HTTP calls basically. The event is stored inside the channel. It can be backed by Kafka, or it can be backed by any memory implementation. It doesn't change the behavior. It's stored in the channel, and then since our service is subscribed, the pod is created with your code, and then the event is forwarded to the pod and then to the systems, to external systems. With channels in Knative eventing, you can create complex pipeline of processing, and you can use Camel actually in every place in this pipeline. You have seen the integration function, the one on the right, so where Camel is used to forward events toward the external systems, but you can use Camel for the enterprise integration pattern capabilities in the middle to route events between channels using dynamic routing. But last but not least, there is this concept of event source. So use Camel to forward events from any component, any system, any external system to a Knative channel. For event source, we have provided also a new cool stuff. So this is the native Camel sources in Knative. This is not the CamelK repository. This is the Knative eventing repository, where we have provided Camel sources. Camel sources are a simplified version of CamelK resource that people that don't know anything about CamelK or about Camel can use. They just configure some properties of the Camel components, and then they can use the Camel component to forward events into a Knative channel. And this is really a cool thing, a really good achievement for Camel. There is a video, but I will not show it, but you can see it when you will have the slides, because now it's the turn of Luca that will talk about CamelK and Quarkus. So I hand over to Luca.
So, hi everyone. So let's talk a little bit about CamelK and Quarkus. So the first question is, what is Quarkus? And from the website, we can define Quarkus as a Kubernetes native Java stack, which is based on the best standard and library, which target GraalVM and OpenJDK. And of course, among of the best library, there is Camel. And Camel play very well with Quarkus. But why Quarkus? The reason why we need Quarkus is that traditional Java cloud native stack are not very well good citizen in a cloud environment, because usually we want to have a better density. And if we compare, for example, a Spring Boot Java stack with a Node.js or Go, we can see that Java doesn't look very well. So Node or Go can have a much better density. Another reason is that in environments such as Knative, where we need a fast startup and we need to be able to quickly answer and request, and eventually we need to scale to zero when there's no more loads coming in our system, the typical startup time of Java is not very, very good. And so how Quarkus helps cloud native Java? It helps because it provides a first-class support for Graal and Substrate VM, which means that we can compile our Java application into native code. So, which means that we are going to create a binary executable very similar to what happened with Go. So we don't even need anymore a JVM. And another very cool feature is that it helps and provides primitives to move most of the initialization logic a build time, which means that when your application starts, it doesn't need to initialize, for example, your JPA stack, but everything is pre-compiled and pre-initialized at build time. And it also provides some hint to the Substrate VM to maximize that code elimination, which means that some code that is not even reachable is not going to be included in your application. And this helps because less code you have and faster your application will be. Now, this is a very, very small overview of what Quarkus does. And to be honest, a new session, a long session will be needed to explain what Quarkus is. But luckily, here at DevNation, there is a session that introduces Quarkus. And so if you need more information about Quarkus, I really encourage you to go and look at that session. But how can we leverage Quarkus for CamelK? So we can warm up the Camel context at build time. So which means that we can discover Camel components, languages, time converter, or whatever at build time. So it doesn't mean, it means that at runtime, Camel do not need to search and inspect your class path to find out component and so on. And which this allow us to create optimized integration, which leverages build time optimization, which means that when you deploy your application, your startup time and your deployment time will be even faster because you have less thing to do. And we can eventually have a strategy in CamelK to generate a native integration. So which means that your integration will be even more faster than what we said before. So this is a very short demo. And this is very, very short because the start type of Camel and CamelK is very, very short. So let's try to run it. And I see if I'm able to stop it at the right time. So in this very simple demo, what I did is run a JavaScript integration, which does something very, very simple. It just uses a timer and periodically logs something to the standard output. But if you look at the start time of Camel, you can see that the Camel context is started in 1 millisecond, and the entire application is started in 15 milliseconds, which means that the startup time, we are able to answer more requests when they come in. And here I'm just playing a little bit with some rolling redeployment to see how fast it is. So as long as you change something in your DSL code, your integration is redeployed and restarted, and everything is very, very, very fast. And that's all about Quarkus. If you need more information, like I said before, Quarkus require a dedicated session, so you can go on the Quarkus website on check the Red Hat DevNation session, past session. So let's talk a little bit about CamelK performance. As you said, you maybe noticed before, Nicola did not even write any information about how the project should be built or how it should be, what are the dependencies and so on. And this is because the operator understands the code. And so because it can understand the code, it can find out what is the lightest runtime for your integration, which means that if the components, the common components support Quarkus, we can eventually leverage Quarkus for the faster startup. And because it knows your dependency set by looking at your code, it can choose the minimal set of components required by the code. And for the same reason, it can optimize Camel and eventually also the JVM based on what you brought in your DSL. And because it understands your code, it can eventually understand that you did not introduce any new dependencies which speed the redeployment of your application even further. At the end, if we compare CamelK with a traditional Spring Boot stack, what we have is an integration which requires less memory and less CPU because it has much less to do. And also, we can improve the redeployment time because with CamelK, the generation of a new Uber jar is not required. And so let's talk about Synthesis, and I will tell you after why. So Synthesis is a web-based integration platform targeted the citizen integrator. And with a few clicks, you can create your integration. We can perform powerful data mapping in a graphical way. You can design your STPI. You can integrate with Treescale for API management. And we are working to bring CamelK as an engine behind Synthesis. And why I talked about Synthesis is because we experimented a little bit and we tried to figure out what are the benefits of using CamelK against the current Spring Boot backend. And the measures are quite good and in favor of CamelK, of course. So if you look at here at the graphics, the blue bar is the CamelK time to deploy an integration or to redeploy an integration. And the green one is the technology used now by Synthesis. So as we can say, the difference is very, very high. So we will bring CamelK for sure in Synthesis. Let's do a very quick recap and see what's next. So what is CamelK? I like very much this sadness. It's a lightweight integration platform born on Kubernetes with serverless superpower. And which means that CamelK run on vanilla Kubernetes, it run on OpenShift, and it run very well in systems or OpenShift or Kubernetes in which you have Knative installed. What's next? So we are working to support Camel 3, which is going to be the next major release of Camel, which has a much better modularization of the core, which helps us to reduce the footprint. We are going to introduce the webhook meta component, which can help component that traditionally may not be able to scale to zero. And we continue the work on Knative side, and we are going to create dedicated CamelK sources for most of the component or all the component, which means that when you deploy a new CamelK source on Knative, you don't need to know anything about Camel, but it's going to be all about configuration of your source. We are going to integrate our CamelK operator with the operator hub, so you can install CamelK in your system much easily. And as I said before, we are going to integrate CamelK as a backend for Synthesis to improve the developer experience. And we are going to provide some better IDE support, so better completion and better integration with deployment lifecycle and that kind of thing. A dedicated CamelK UI and some support for testing your route, within CamelK and your cloud environment, as well as some better integration with CI tools. And so that's all from us. And thank you. If you like CamelK, go on GitHub and start it, use it, and contribute, because we really love contributors. And now is up to you, Bor.
Okay, well, we have totally run out of time. We went over our time limit for today. Make sure you get the presentation materials out of this platform. You'll see them down there at the bottom. You can download the slides from there. Hopefully you guys got good information from today's session. I actually really enjoyed the Chuck Norris demonstration. I even pasted some of the Chuck Norris jokes that I received into the chat for people to enjoy there. But make sure you do check out our previous Dev Nations on Knative. We have 2 of those, as well as a 1-hour big session on Quarkus itself. So those 2 I'd highly recommend. I want to thank Nicola and Luca. You guys did a great job with those demonstrations. I really enjoyed it. Really, the Chuck Norris demos are really funny as hell, quite honestly. So thank you so much for that. All right. Well, everyone, thank you and have a great day.